Okay, thank you, Catherine. All right, everyone, welcome to Boston University and the Hurry Institute for Computing. Good morning, good afternoon, or evening, depending on where you are. My name is Eric Kalachik. I'm the director of the Hurry Institute. Today's event is co-sponsored by Boston University's Institute for Sustainable Energy, and we are delighted to continue our speaker series at the interface of computing and sustainable energy here. Quick word about the Hurry Institute. The Institute at BU is dedicated to leading integrated initiatives in research and technology development. We target a broad set of disciplines at the nexus of the computational and data sciences. As you can see from the schematic there, we have core strengths in cloud computing, security and data privacy, AI, as well as a network of over 300 plus research affiliates across a vast spectrum of disciplines. The Hurry Institute is positively impacting people everywhere. Here's a quick sense of the program. I will finish up in just a minute or so with the welcome. I will turn it over to Scott Hurst, who will be today's host. We will then have a presentation from our speaker of about 35 to 40 minutes, followed by a Q&A session of about 15 to 20 minutes. A little housekeeping, we ask that if you have questions, which we hope you do, that you enter them in the Q&A feature of the Zoom, not the chat. And all questions will be held, just so you know, until the Q&A portion of the event. This will be a review if you've joined us previously, or to give you context if you haven't been able to. So this is a distinguished speaker series where we aim to bring up-and-coming innovative speakers with bold ideas in computing-enabled and data-driven areas of research to BU. These take place once a semester. The series hosts a handful of speakers clustered around a common theme, generally over a 2-week period, and then each speaker gives a broadly accessible presentation followed by the Q&A. This particular series is focused on humanity facing the defining challenge of learning to prosper within the ecological limits of the planet. AI and machine learning offer, as we know, powerful new tools that could open new paths for humanity to embrace sustainability. This series is aiming to bring together leading thinkers at the intersection of sustainability and AI. I do want to point out it's been organized by our Institute's junior faculty fellows, so I'd like to thank them for all their efforts in that regard. In particular, Garrett Johnson, Assistant Professor of Marketing at BU, Ashed Onbar, Assistant Professor of Department of Electrical and Computer Engineering, and today's host, Scott Hurst, Associate Professor of Law. We heard previously from Claire Montaglioni about deep unsupervised supervised learning for climate informatics last week. Earlier this week, we heard from Aisha Wolcott-Bryant about AI's potential for healthcare to mobility in Africa. And today we're of course going to hear from Francesco Fuso Nerini. Please also plan, if you're able, to join us for the culminating portion of this event series, which would be Friday, when we get all these speakers back together. These tend to be a lot of fun, and it's a lot of fun to watch and interact with them as they all come together around these topics. Then finally, let me just introduce today's host, and then I'll turn it over to him. So Scott Hurst first joined BU School of Law as an associate professor in 2018. His research seeks to explain phenomena in corporate law, securities regulation, and regulated areas, and to inform policymaking on these subjects. His work combines empirical methods and conceptual analyses from finance, accounting, and economics, with close attention to institutional environment within which corporations and investors are making decisions. Before joining BU Law, he served as a research director of the program of institutional investors at Harvard Law School and practiced law in a number of additional locations. He holds a Doctor of Doctor of Law and Master of Law degrees from Harvard Law School. And Scott, I'm going to turn it over to you.
Thank you, Eric. It's now my great pleasure to introduce our featured speaker today, Francesco Fuso Nerini. Francesco serves as Associate Professor at the KTH Division of Energy Systems and is the Director of the KTH Climate Action Center. His focus is on addressing multidisciplinary sustainable development related issues, including how future climate change and action, energy choices, and AI will affect the achievement of the climate and sustainable development goals. Before joining the division, Francesco worked and studied in 9 different countries, ranging from academia to national and international organizations. He currently has research affiliations with the RFF-CMCC European Institute on Economics and the Environment in Italy, with the Payne Institute for Public Policy in the United States, with the UCL Energy and Development Group in the United Kingdom. He's undertaken postdoctoral work with the UCL Energy Institute at the University College in London and the World Energy Outlook team with the International Energy Agency. He's also worked at the Italian National Agency for New Technologies, Energy and the Environment, and as a guest researcher, both in Australia at the Melbourne Energy Institute and in Brazil at the Universidade Federal do Pará. He holds PhD and docent degrees in Energy and Environmental Systems Analysis from KTH, and Masters of Science degrees in Environmental and Sustainable Energy Engineering from Politecnico di Milano, from Universitat Politecnica de Catalunya, and from KTH. Before we get started, I just want to remind everyone to follow the Hariri Institute channels and to get the latest updates on upcoming events. And also today's talk is being recorded and will later be available on the Hariri Institute's YouTube channel. Thank you all for attending and joining us, and please join with me in welcoming Francesco Fuso Nerini. Francesco.
Yes, thank you for the introduction, and let me share my screen. So yes, today I would like to share some results from a recent multidisciplinary study that we did looking at how can artificial intelligence affect positively or negatively the achievement of each one of the targets of the Sustainable Development Goals. And maybe a bit of background to that. As you might know, the Sustainable Development Goals were adopted in 2015. And consist of 17 sustainable development goals, which range across a wide array of topics, going from eradicating extreme poverty and hunger to health outcomes, equality outcomes, access to energy, and fighting against climate change, health of ecosystems, and partnerships. These 17 goals are detailed by the 169 targets and more 200 plus indicators that are within them. And since the creation of the Sustainable Development Goals, these have increasingly been used by researchers, policymakers, and project developers to try to direct research policy and projects. Well, the SDGs increasingly in literature, but also in international organizations and also national organizations, they're being more and more used as a powerful tool, yes, to collect, understand, and analyze research and trends, but also for cross-sectorial coordination and for directing all of these, again, research policy and projects. On the research side, this is quite a broad field, and this is just some of the outputs that we were involved in, looking at what we discussed today, so the role of artificial intelligence for achieving the SDGs. But also we did a number of other studies looking at how to direct the climate and energy policy in line with what the SDGs require. But jumping into what we look into today, well, the extended study has been published in Nature Communications. So if you're interested in this, I can only touch on a certain amount of details today. But if you're interested, I would invite you to read the paper. And this paper has been very well received internationally. It was published in 2020. Accessed, as you see, or right now more than 150,000 times, and also featured in national and international news. And basically, it gives a forced overview of how AI, and I will define what we mean for AI in just a couple of minutes, how AI might affect positively or negatively the Sustainable Development Goals achievement. And what we appreciated is that some of this coverage of this study defined it as an exciting new intersection between the fields of AI and sustainable development. So broadly, we wanted to answer two main questions. So first of all, can AI, answer the main question is, can AI act as an enabler or an inhibitor for each one of the 169 targets of the SDGs? And as you can imagine, I mean, we were looking before at the Sustainable Development Goals, and something that you have noticed is that they span across many disciplines and many knowledge areas. So to try to do any of these type of studies, you really need to go across disciplines and have quite a broad knowledge across all the topics that might be important for such an assessment. And so this is the authoring team for that specific study. And what we did is really trying to map the knowledge areas that we needed for such an assessment. We assembled a team that could try to answer this question. So this study was co-led by myself and Professor Ricardo Vinuesa. But also, as you see, we have very different specializations in here. So we have people that worked on AI fundamentals and AI and social interactions, AI ethics, but also on the fields that might be impacted by this revolutionary set of technologies. So looking at biodiversity, ecology, energy and climate. And also, for instance, we have collaborated with quite a famous professor in the US, Max Tegmark, professor at MIT. But first of all, AI is a term that has been used quite a lot and very broadly. So the first step of this study was to define what do we mean for AI in this paper. And of course, different studies and different organizations even might have different definitions of what does AI mean. So for AI in this study, we mean for software technology with either capacity of perception, for instance, software for face recognition, capability for decision-making, such as making the medical diagnosis, capability for prediction, looking, for instance, at the algorithms that are used for some of the most recent weather forecasts, capability of automatic knowledge, extraction, and pattern recognition from data. For instance, an interesting application that recently has been developed also for need are algorithms that can discover fake news in social media. Interactive communications, I think more and more each one of us is interacting with social bots and chatbots. And more broadly, logical reasoning, for instance, developing some sort of theory from certain premises. This is a very broad definition of AI, as you can see, which encompasses fields like machine learning. But maybe before going forward, I would like to ask all the audience that is connected if you would like to answer a quick question in Mentimeter. If you've not used Mentimeter before, it's quite simple. You go on your phone or on your computer to menti.com. And using this code, 98789478, you should be able to vote. So I'm just asking my other panelists, do you see the Mentimeter screen?
Yes.
Perfect. So I'll just wait half a minute for you to write a couple of things. And of course, it's a very broad question, so you can give your first reaction. badly is the first answer. I hope today we discuss a bit more nuanced. It can be ethical or unethical, lots of possibilities. Don't know. That's probably one reason to be here. Could help healthcare. Yes, we will have some examples on that. Volatility can have impact on fairness, on the environment. Highlight research gaps. We will discuss about that. Cost saving. Okay, can come back to this later. So please keep going on. We will look at this again. But going back to the presentation. So I mean, you already see it's quite a broad field, and I think it can be a bit polarizing as well. And as you can already imagine, it has implication across all our societies. Just two words. I'll not go too much in detail about on the methods, but if you look at the paper, you will see in detail how this was developed. And especially you'll see there is a long supplementary material. So in a simplified way, what we did is an expert-driven large literature review, let's call it like that, in which we did actually 169 small literature reviews. So for each one of the targets of the Sustainable Development Goals that are 169, we try to understand, based on existing evidence and literature, how AI could either affect or be an enabler or an inhibitor for that specific target. So for instance, here I represent some of the targets for Goal 1, which is, or SDG 1, which is end poverty in all its form everywhere. So by downloading the paper, which is open access, you can also see all the single evaluation. And also, I will discuss the results divided in three main pillars: society, economy, and environment. But jumping into the results. So first of all, a summarized view. We could see that, again, divided in these three categories: economy, environment, and society, we can see that published evidence shows us that mostly we found positive effects of AI on the achievement of the SDG targets. So around 80% of the targets, we found evidence that there was a positive impact, and around 35% of the target, we found evidence that there might be a negative impact. I'll discuss later. This, of course, has to be better discussed. There are some biases here because scientific literature tends to publish more positive than negative results. And also, I would like to highlight that it's not a one-to-one comparison. Maybe one negative impact might be, in certain local context, more important than 10 positive impacts. But these are the broad results. And now we go a bit more in the detail. And also, I'll not go too much in detail here, but this is the same representation, just with a different type of view, where we have each one of the SDGs on the outer wheel, and the percentage of targets that are affected positively on the left or negatively on the right by AI represented. And also we have two shades here because we also did an assessment of the quality of the studies that we found on these interlinkages. So this is at the basis of the detailed results that I'm going to discuss now. So, also about this representation here, you can see even more disaggregated results. So again, here are all the Sustainable Development Goals divided in these three categories: society, economy, and environment. Of course, the categorization is not strict. There are some parts of society or the SDGs allocated to society that can fit in another category, but it's just for starting to discuss and understand the results. But for each one of the SDGs, here we represent each one of the targets. So for instance, this is SDG 1 on no poverty. It has 7 targets, 1, 2, 3, 4, 5, A and B. And when one target is highlighted in green, we found evidence of a positive impact of AI. When one target is highlighted in orange, we found evidence of possible negative effects. So going a bit more into detail. So starting from some of the positive effects, we found that broadly AI could have some positive effect on poverty, on economy outcomes, and on industry. So AI-enabled technology might help new jobs and productivity. And there are also some interesting examples. So for instance, satellite data combined with machine learning is being used to try and understand in a certain country where are areas of poverty, which then can be used to direct government action on that. However, and we will see this kind of duality across this talk, there are always some positive aspects, but also some potential negative aspects. And then, of course, if the positive or the negative aspects will prevail, of course, will depend on how the situation evolves in each local context. And also it will depend, for instance, on how governments act on a certain possible negative impact. And something that, of course, has been discussed quite a lot is the possibility of AI and, in general, advanced technology to increase inequalities. So, as you can imagine, certain jobs might be lost. So, while there will be more jobs related to AI-connected activities, certain jobs that can be replaced by these can be lost. And also, there are uneven opportunities to access AI resources. As you can imagine, in a technology advanced rich country, or a technology advanced rich country, will be able to better use some of these opportunities than a less technology advanced poor country, which of course might result in increasing existing inequalities. And something that we have seen more and more, and it's been discussed more and more also in the news, is how certain algorithms might polarize societies and increase discrimination. So, for instance, in social media, certain algorithms that tend to cluster a group of people based on their beliefs and their ideas end up making this polarization even broader. And then, of course, a more polarized and unequal society can have in turn impacts on peace and stability. When looking at the energy and climate transition, there are some good news thanks to these new algorithms. So AI algorithms can potentially enable smart and low carbon societies, helping a transition to a more green economy. So one example is that variable renewables might, or it's not that simple to create electrical national system with high integration of variable renewables such as wind and solar. However, certain algorithms can help integrating more and more of those, also by matching the demand in the single households or in the single industry of electricity to be matched with the production. And also it can help to create more sustainable, smart, and low pollution cities. And of course, pollution is still a large problem in Europe and also in other places. And some AI applications can also support the management of natural resources and resource efficiency. One example is, for instance, that satellite data together with algorithms is being used to track areas where there might be oil spills from oil extraction in the sea. And again, it's a double-edged sword. So at the same time, AI can have large effect on the global energy demand. After this introduction, I'll go a bit more in depth in some of these dynamics. AI or these algorithms are based on large transfers of data. These transfers of data and processing of data is associated to very big data centers that can use a lot of electricity. There's still a lot of work going on to try to understand and estimate how much this impact on the electricity and energy systems can be. But some of the more pessimistic scenarios say that from a current level of around 1.5% use from ICT of global electricity demand, we could go up to 20%. But of course, it depends on scenarios and assumptions. So after this quick introduction, I would like just to focus on a couple of themes that I think are particularly interesting when talking about AI. And the first one is AI for a low carbon society. I already mentioned that AI can help increasing the advancement on Sustainable Development Goals 7 on affordable and clean energy. I already mentioned how AI can help integrate variable renewables by enabling smart grids that can match electrical demands to times when the sun is shining and the wind is blowing. But also, these algorithms can be used to greatly increase energy efficiency. So, for instance, by better managing energy demand at homes, allowing smart homes and, for instance, smart charging of electric cars, and so on. However, again, there might be some things that need to be addressed before all these positive aspects are realized. I mentioned that energy demand could skyrocket for AI applications. One example that I think I mentioned before is Bitcoins, where a completely new, I'll mention after, where a completely new application resulted in really, really high energy demands. And another aspect that, of course, still needs to be addressed, even though there is a lot of work going on, is cybersecurity. And let's talk, for instance, about energy systems, but any type of infrastructure. So, as you know, energy is needed for everything we do in our societies. And then a more and more digitalized energy system does make it more vulnerable to cyber attacks. And so there is a lot of need to work and improve the security of these systems so that one of your most important services is not vulnerable to hackers in other parts of the world or in your same country. It's also quite interesting to look at how AI fits with the action on climate and into the achievement of the Paris Agreement. And also here, again, there are some positive and possibly negative aspects. One thing that is very interesting is how AI and these algorithms can help climate adaptation. For instance, by helping the understanding of climate change. So there are better and better algorithms that can support the prediction of forecasting of extreme weather events, which, as you may imagine, is very important. So having just a few more hours heads on a possible extreme weather event can mean life and death in certain parts of the world. But also in the longer term, it can support understanding how the crop system in a country will work on a specific weather year. And all of these benefiting how we can adapt to an increasing climate, to an advancing climate change. And again, also effects on climate mitigation. So how do we reduce emissions and stay within the Paris Agreement target of having a global average temperature change well below 2 degrees and hopefully aiming at 1.5 degrees. But again, some unexpected things, and I think this is a very interesting that was created in the ICT sphere, created a whole new energy demand, which has quite large repercussion. So cryptocurrency and bitcoins are now using as much electricity as some nations are. So, and of course, with all the greenhouse gas emissions that are related to this. So again, there might be completely new applications also coming in the next few years that might have similar outcomes. So this is something, of course, to keep in mind. And I think, especially in cities, as we mentioned, the role of AI might be very interesting. So cities are an interesting melting pot where we have more or less all the different sectors. So we can have from, of course, a lot of people living together in buildings. We have industry. We can also have urban agriculture, and so on and so on. So a lot of things happening together. And a lot of work is ongoing on creating smarter, more livable, and low carbon cities. And so these cities will encompass more and more technologies, such as electrical vehicles, smart appliances, other infrastructure services, for instance, how we deliver water to each one of the apartments, and even looking at air quality. So there is quite a lot of areas in which AI might improve the standards of living in cities. A second focus that I would like to mention that is also discussed quite a lot is the role of AI in economic growth and also inequalities. So we're looking at economic growth, and here on the right, I mentioned SDG 1 on no poverty and SDG 8 on decent work and economic growth. AI has been coupled with substantial growth in many sectors and also in the appearance of new jobs. And this is mostly related to new technologies and increased productivity and new businesses. However, as I mentioned before, replacing possibly new jobs where educated, technology-capable people have much more benefits than uneducated or not technology-capable people. And this is a figure that I think is quite interesting to see. So if we look back at the 1990s, the combined revenues of the big three, so General Motors, Ford, and Chrysler's, were almost identical to those of Silicon Valley big three, Google, Apple, and Facebook in 2014. So similar revenues, different years. However, the latter, so the Silicon Valley one, had 9 times fewer employees and were worth 30 times more on the stock market. So this is an interesting thing to understand the dynamics for jobs and wealth creation associated to AI. But again, a lot of new frontiers. And I think everyone realizes that in the recent COVID crisis, AI and this type of algorithms played a key role in the production of new pharmaceutical products and in the production of vaccines faster than ever it was done before. But again, the big word on, let's say, the potential negative facts is potential inequality. And the first one that is mentioned is, of course, polarizing social media usage. And on the right, I think you all remember this riot at the Capitol. Of course, it can also be traced back to this increasing polarization, also due to social media. And for instance, a term that has been used more and more recently is the term big nudging. So using big data and AI to exploit psychological weaknesses to steer decision. So how these algorithms are being more and more targeted for different types of outcomes, being it steering a group to vote something in an election, or steering a group to buy a certain product. So yeah, a lot of work still has to be done, and well, it's being done, but has to be done on ethics. And another, of course, issue that arises from this is also ethics, but ethics in which country? Depending on where you are. So if AI technology and big data are used in regions where ethical scrutiny, transparency, and the democratic control are lacking, AI might enable nationalism, hate towards minorities, and biased election outcomes. Another negative example is that has to be solved is also algorithm discrimination. So if algorithms are not well trained on the data, they might reproduce and learn societal biases. And here are some other examples. So if we look at inequality, so SDG 5 on gender equality and SDG 10 on reduced inequalities, we can see problems related to the fact that the vast majority of collected information is on men, such on economic data, urban planning, and medical data, which creates then problems with the applications and with the software that is created based on that data. So just going, so again, what I showed you is, let's say, a small part of the outcomes from this, I would say, rather large study and overview of how AI might affect SDG outcomes. So one of the key things now is understanding, okay, based on that, what are the key research gaps that we should try to address when looking at AI? And to do that, maybe one thing that we try with this team of authors is to try to understand a bit what are the key dynamics here in place when looking at AI and its interactions with individual, with policy, and with the public. So, well, a wide range of new technologies are being developed very fast, significantly affecting the way individuals live. And of course, vice versa, technology tends to satisfy any new need of individuals. At the same time, fast technology development affects government through the need of appropriate piloting and testing. And at the same time, governments provide the legislation and standards to technology. The key problem here, and maybe something I should have mentioned here written on the top, is that thicker arrows in this representation indicate faster change. So again, the key problem here is that neither individuals nor governments seems to be able to follow the pace of these technological developments. And of course, there are other important interactions. So the government affects individuals through policy and legislation, and individuals require new legislation, which is consistent with the changing circumstances for the government. And of course, in all of these, we also have interactions with the environment. So the environment interacts with technology by providing the resources needed for technological development and is affected by environmental impact of technology. So in all this complex set of interactions, again, we have technology that is developing very fast, and individuals, government, and environmental resources that are struggling to keep the pace. So based on this broad overview, we started discussing, okay, what do we need to know? What do we need to work more on? So that we ensure that AI applications are beneficial for the future achievement of the Sustainable Development Goals. First thing that we see is that AI is mostly developed in technology advanced nations. And as you can imagine, that results in addressing issues that are mainly relevant for those nations where AI researchers live and work. For instance, many systems applying AI technology for agriculture, for instance, to automate harvesting or optimize timing, are located within wealthy nations. And these, of course, can result in increased inequalities. If richer, wealthier, technology-intensive nations are more and more well off while leaving behind poorer nations or poorer areas within even the same nation, that's an issue. There is a need to develop AI that works for all nations. The more we enable the SDGs by deploying AI applications from autonomous vehicles to AI-powered healthcare solutions and smart electrical grids, the more important it becomes to invest in the AI safety research needed to keep those systems robust and beneficial, basically to support and prevent them from malfunctioning or getting hacked. And also, I think I mentioned it at the beginning, we did find in this large review more positive effects of AI. But at the same time, there is a bias in AI research and industry towards publishing positive results. So what is needed here is having more work investigating also the possible negative effect of AI. And also, yeah, and sorry, maybe a last thought on that, because as it is now, it is likely that the AI projects with the highest potential of maximizing profit will get funded. And so without control, research on AI is expected to be directed towards AI applications where funding and commercial interests are, and not necessarily where the most societal benefits are. And of course, there is, as we mentioned, quite a lot of need to work on the ethic standards and the ethics-driven legislation and certification mechanisms for AI systems. So just a couple of conclusions as the presentation is finishing. I think you already realize from what I presented that AI in its various forms, as we described before, is already affecting everyone's lives. And these effects that we already see are both positive and negative. And positive effect, for instance, we mentioned smart grids and cities, e-health, and many, many other applications. However, negative effects are very important. And we mentioned big nudging. So again, using AI and big data to nudge entire parts of a population into doing something. And another example that I haven't started discussing is nations even thinking about using citizen scores based on these type of algorithms. And that will only increase. And again, how this goes, in which direction it goes, if it's positive or negative, it really depends on a number of decisions that will be made in different parts of the world in the next years and months and years and decades. So potentially, as we saw, some of these applications can enable an AI-fueled sustainable development. But as technology evolves faster than citizens and governments, there are still large research gaps to manage this transition. And also, I mentioned the vulnerability of critical infrastructure. So again, if our water, energy, IT, and health systems are all managed by complex algorithms, it's really important that these are secure and protected from cyber attacks. Well, basically, substantial work is needed for overcoming certain key gaps for AI. And in our work, we mention gaps in transparency, gaps in safety, and gaps also in the ethical standards for the deployment of AI. So that was all for the presentation. And again, there is much more detail in the published studies. So if you have interest in these, really happy to have a discussion now, but I I would strongly suggest that you also look at the published study.
Francesco, thank you very much. We now have some questions for you, and I would encourage anyone attending, if you have additional questions for Francesco, please write them in the chat, in the Q&A, I should say, and then I'll raise them for Francesco. But Francesco, let me start by asking, how do you think your expert-driven views differ from the popular understanding of the opportunities and challenges that AI might present for sustainability? And if there is a big difference, how would you think about overcoming that?
Sure. Well, I'm not sure if there is a big difference. So I would say that the advantage of this type of structure study, and again, I didn't go too much in depth in the methods, but to be more precise, is an expert elicitation method in which a variety of experts also look at literature and try to do this assessment. So the main advantage there is really having a structured understanding across all these different goals of the possible effects that AI might have. And again, enabling this collaboration across experts really helps highlighting, let's say, transversal issues that one might encounter in the development of AI. So I would think that maybe while one person from the public might have, or even one single expert might have a good overview of one single issue, maybe within the energy system, within the water system, doing this kind of structured overview across the 169 targets of the SDGs really helps to see kind of the broad development of this broad field and give some key recommendations on how to steer it.
Thank you. Our next question is about the potential negative impacts of AI. And the question asks, does the deployment of AI equipment or networks require a significant resource input, such as, say, electrical consumption? And if so, how do you think it might affect social inequalities, such as in developing countries? And might there be any ways to mitigate that?
Yeah, that is a very good question that we discussed in the study. First of all, yeah. So all estimates, again, I mentioned there are different scenarios, some a bit less, but all estimates expect a big raise in electricity demand due to AI and more broadly ICT. And then, of course, if you live in a country where you still have issues for access to electricity, as I think the latest number is around 800 million people still have lack of access to electricity, they cannot get all the benefits from this transition. So that, of course, can create an increase inequalities. And then it's not only about electricity, of course, the digital transition requires a lot of critical minerals and materials that also give some strain on the supply chains, and who again benefits the most from these. So of course it's a big issue, which I believe there's no simple solution to, but of course it needs to be looked in the different local contexts.
Francesco, another question is, are there policy interventions that you think can enhance the ability of AI to achieve its potential to help the sustainability goals, or to reduce the downsides of AI? And how might we identify some of those policy interventions? And
yeah, thank you. Yeah, absolutely. So and I think it goes a bit in the discussion that I started in the presentation. So right now, many of the applications that we see are more twisted towards commercial interests. And sometimes, of course, commercial interests are also in line with some advancements on societal benefits. However, there are still quite a lot of gaps where potential applications with high societal interest have not been developed because maybe there was not so much of a commercial reason to do so. So one key thing, of course, can be for, depending on the local context, for government and policy to find those instances where opportunities with AI have not been taken, even though they could have good positive impacts on society or on local environment.
Francesco, thank you. Another question that we've received is how will members of the general population that might not be experts or that might not have access to the back end of AI be able to identify when results from AI are biased, and then who should be responsible for maintaining the ethics with respect to these questions?
No, of course, and it's also a very good question, because in many cases, these AI algorithms are defined as black boxes where you don't exactly know what is happening. But yeah, I mean, several organizations and nations are trying to move towards AI ethics standards. So in this case, what we propose is that there really is a need of a push from government, from the top down, so that the right framework and ethical standards are in place, so that not everyone that uses these algorithms needs to understand the nitty-gritty of the single functioning, because that's not possible. I don't think that a single expert can understand all of these.
And maybe to follow up, Francesco, to what extent, how well do you think governments are already and policymakers are already focused on these questions? And how do they need to change? And also, who within policymaking organizations should be thinking about this? What are the appropriate bodies for considering some of these questions?
Also very good question. And I would like to flag that also in our authoring team, we had a professor in AI ethics. So I can try to answer, but I'm of the extended group, I'm not the best person to answer. But I know that in several countries, but also in collaboration such as the European Union level and so on, there are more and more agencies being created to look at the digital transition. I know that in Sweden, for instance, that's within the Ministry of Infrastructure, that tries to look and collaborate with other countries to give a framework for all of these. But again, one issue that I mentioned is not so much how one country is getting it right, but also how to get it right across different countries, because then if you go in countries where this regulation is not in place, or where there's less interest to have a regulation on the ethics of AI, then you might have the largest issues. But again, I will say I'm not an AI ethics expert, so I could suggest to read some of the work of our co-author. Her name is Virginia Dignum, and she's professor in AI ethics.
This is a fascinating question as to how one manages this kind of across countries, especially if there's the possibility for these things escaping or not being well correlated with national borders. So another question we've received is, so you've mentioned that by 2030, the electricity demand share of AI related activities might be as high as 20% of total demand. And if renewable energy adoption fails to cover this demand, do you think that AI and AI writ broadly, including things like blockchain and cryptocurrency applications, could increase environmental emissions?
Yeah, the conditions of these questions, definitely yes. So if we have a high increase in electrical demand, and that's not zero carbon or low carbon electricity, then we have an increase in greenhouse gas emissions, which goes against the commitments on the climate. There is work ongoing, both on one hand to make these algorithms more efficient. It does not necessarily need to be that some of these processes are this computationally efficient, this computationally heavy, that we need to have such an increase in electrical demand. But at the same time, again, it goes in the different countries. How do they approach climate change? And then let's go to the other part. If we have a fully decarbonized, zero carbon electricity system in a country, even if demand rises, then it doesn't have an impact on the emissions. So it's really all these different dynamics put together.
We're almost out of time, but if I made one more question for you. So regarding the potential of big nudges that you mentioned, what behavioral antecedents can AI influence either at the individual or at the societal levels? And do you see implications for allocation decisions and for political economy?
Again, I learned a lot through this study with all these experts. I wouldn't say this is exactly my my field, but I try to give my answer. Well, the influence of this kind of big nudging, I think, can be seen in quite a few events, and I think we all heard in the news when there's been tries to steer an election in one direction or the other through certain types of algorithms, or, I mean, in a way also by commercial products. And I think, yeah, some, let's say, older political entities are struggling to cope with this change and to cope on how, for instance, some elections might go one way or the other based on some of these dynamics. So yeah, I'm not sure I can say much more, but of course it does have an influence in this type of political considerations.
Unfortunately, Francesco, that's all we have time for. I apologize to those who asked questions that we didn't get to. I should mention that the video for today's event will be posted on the Hariri Center's YouTube channel, and you can also catch any of the other talks in this series that you might have missed on that website as well. And finally, on behalf of the junior faculty fellows and the series organizers and our co-sponsors, including BU's Institute for Sustainable Energy, thank you very much for joining us. And thank you especially to Francesco for presenting. And we hope to, Francesco will be at our series panel on Friday, and we hope that everyone else can join us then as well. That will be this Friday, February 11th, from 11 to 12 a.m. Eastern Time. Thank you very much, Francesco, and we wish everyone a good day.
Thank you.